And here we have our virtual machine. Let me close our previous example files. Close. And we are going to create a new file. Let's create our common imutils file first. So let's imutils.py. Okay, now let's create the imutils file. Importing the libraries, import numpy as np, import cv2. Then we are defining the translate function. Define translate. The first argument is image, the image that we are going to translate. The second argument is the x coordinate and y coordinate. It's not actually coordinate, it's just a value, x value and y value. And inside the function, make sure you are intending 4 spaces. And inside the function, we are defining our translation matrix m equal to np dot plot 32. So this is our translation matrix. The first translation matrix is 1, 0, x, which is our x value. Then the second row will be 0, 1, y, which is our second row of the matrix. Okay, it's a matrix, so we have to define one more square bracket here. Okay, so this is the first row of our translation matrix, and this is the second row of our translation matrix. And now we are going to shift the image. So shifted equal to, and for shifting we are going to use the var affine function. So dot var affine, then image, comma, translation matrix, comma, the width of the image, which is image dot shape of 1, and height of the image, which is image dot shape of 0. Okay, so we have shifted the image. Now we need to return the shifted image. Return shifted. Save this file, Control S. And now we have our library. Let's now proceed with the actual main program of our translation. Create a new file. And in this file we can reuse few code. For example, I'm opening the file, the first file, or fetch display save file, open, and here we can use till here, importing the libraries, then fetching the argument. If you are not sure how it works, please go back to our previous session and see the explanation regarding how this fragment of code works. We are importing the libraries, we are fetching the argument, which is the path to the image, then we are reading the image and having it in this variable. So I'm copying it, just paste it. Until here it's fine. Now we are going to transform the image. We are going to translate it using our function, the common function that we defined. Before that, we need to save this image. Let's save this as translate.py. So we have the actual image, the original image right now with us. So let's define it. Shifted image equal to, we are going to use our imutils. I'm sorry, actually we forgot to import our imutils. It's better to import the OpenCV as the last import after importing everything. So let me import, and now we are going to import the common file that we write previously, which is imutils. And now we can use the function that we defined inside the imutils here, which is imutils dot, this function we are going to use. Translate, the first argument is image, then x, then y. Translate, the first argument is the image, this is the image, then the second argument, here we are going to shift the image down, so we have 0, then 100. Whatever the value you wish to provide, you can provide. So without writing all these code, we can just have it in a single line. We will retrieve the translated image using a single line of code. That's the advantage of keeping this set of code as a common file. And now we are going to display the shifted image, cv2.imshow shifted down image, and the image is shifted. This is the image, and we are defining a wait key cv2 dot wait key of 0. Control S. Now let's try to run this file. We need to have the argument. Yes, this is a, let me clear it out. Python 3 space translate.py, then we have to provide the argument as image, this one, image dot slash OpenCV slash our cat image, cat.jpg. Press enter, and we have an error. You have invalid syntax. Oh, I think we forgot to include the colon here. Okay, now let's run it once again. Yes, you can see the image has been shifted down. You can see a blank area here. The image has been shifted down. So we have successfully executed our shifting down of the image. Let's do few more shifting in which we are shifting left and right and up of that same image. Click on it and press any key. Now let's do one thing. Let's shift image down. Now let's use the same code. 1, 2, 3. Okay. Shift image up, shift image left, shift image right. Okay, I'm just trying to demonstrate, that's all. Shifted up image, shifted left image, shifted right image, and here the positive values of ty will shift the image down, negative values will shift the image up, and negative values of tx will shift the image left, and then positive values of tx will shift the image right. And you can also use combinations of this, like for example you can use it like shift image right and down. So for down you can have any positive values of ty. So let me shift the image down to 50, and to right we can have the positive value itself, so 150. You can use combinations like this also. Now let's try to run the program, and you can see the image shifted down, then shifted up. You can see the space here. Then we have the left shifted image. You can see the space here, and the right shifted image. You can see the space here, and you can see the combination. You can see a downshift and a right shift. So this is the way how we can use it easily by using the OpenCV warp_in function in order to translate the image. And that's all in this session. In the next session we will see another transformation called rotation, where we are rotating the image an angle based on the rotation angle we specify. So see you soon in the next session. Have a great time. Bye bye.